Hey guys, in this tutorial I'll be teaching you how to train your custom YOLOv8 classification model from scratch. I'll take you through how to structure your data. I'll take you through step by step the folder structure and how to train this model on our local machine. We are not going to be using Google Colab. I'll teach you how to train this model with your own local machine. Then at the end of this tutorial, after we train the model, we'll test this model by integrating it with a Streamlit app where you just drag and drop images and get your predictions on them. If you like this tutorial, if you like computer vision, AI and Python related projects, subscribe to this channel and also share this channel with others so that they will also benefit from tutorials like this. Enough with my self-promotion stuffs, let's roll into it and train our custom YOLOv8 classification model. Alright guys, so we'll start off by looking at the data and the folder structure we need to train this model. So for data, we'll be using images of cats and dog. In your case, you can use anything you want to train for, provided you have the images. So let's say you want to classify cats and horses, you want to classify bottles and let's say ants, you can go ahead and do it, provided you have the image. All you need to do is to follow this tutorial step by step and make sure each and every step is implemented as well. So on my desktop, I have a folder called cats and dog. And this cat and dog is the root folder. So this is our main folder in this case. So inside it, we have train and validation. So you create a root folder called cat and dog. In your case, you can name it anything you like. Then inside it, you have a folder named train and you have a folder named val or validation. So the training folder will contain the images we are going to use to train our model, and the validation folder will contain the images we are going to use to validate our model during the training process. So when I open train, you can see we have the classes cat and dog. So when you open cat, we have some images of cat. And in this case, I have 80 images for each class. When you open dogs, so you can see we have the same. So you have a root folder called cat dog, and inside it you have train and validation, and inside train you have your classes. Inside validation you also have the same thing, cat and dog, just that your validation data is always less than your training data. So I have only 20 images for validation in the case of both cat and dog. So this is how you need to structure your data for training the classification model. So in case you are having many classes, maybe you have 3 classes, you can go ahead and just add them here. So it can be cats, dogs, goats, bottles, and whatever you have, you can just put it right here. But in our case, I'm just doing only cats and dog. Okay, so that's it. So you'll be like, okay, fellas, after training the model, what images will we use to test the model? I have that images here in a test folder. So you can see we have some few images here of dogs and cats, and we use these images to test the model after training. So these images the model has not seen before, so use it to test it to see how well it performs on these images. So since we'll be training with our local machine, we'll go ahead and create a new folder, and I'll just name this folder YOLO classification. So all I'll do is to open this folder with Visual Studio Code or VS Code. And in here, the first thing I'll do is to create a main.py file. Our main.py file is ready, and I'll just run this. It will prompt me to select a Python interpreter. So over here, I have Python 3.7 version installed. I'll just choose it, run again, and that's it. So now we have the terminal, and the first thing we'll go ahead and do is to create a virtual environment. I have a tutorial on virtual environment, why it's important. The link of this tutorial will be in the description so that you know why you should always create virtual environments for your projects. So to create a virtual environment, we just type Python -m, then v, and then you give the name of the virtual environment you want to create. So I'll type YOLO in our case. This will go ahead and create it, and you'll get a prompt. The virtual environment has been created. Do you want to use it? I said yes, I want to use the virtual environment. The next thing is to activate this virtual environment, and a simple way you can do this is to kill the terminal and rerun your code. And now you can see our virtual environment is being activated. You can see it right here, YOLO. Okay, so now go ahead and install some few packages for this particular tutorial. And the first package we install is Ultralitis. So I'll do pip install Ultralitis, and this will go ahead and install it. So this is the installation process. It will install the Ultralitis library together with other packages for us so that we can train our model. So you can see we are installing Pandas, Storage Vision, OPCV, NumPy, and so many other packages as well. Alright guys, so our installation is done and the whole process is done, so we can continue by training our model. Let me clear the terminal, and okay, over here the first thing we need is to import YOLO from Ultralitis so that we can instantiate it to train our model. So we just type from Ultralitis import YOLO. The next thing you need is your data path, the path to your root folder. Guys, pay attention to this. You need the path to your root folder. So we'll just define a variable here called data path, and this will be equal to the path to our root folder. So I'll just move over to the desktop, open this root folder here, and then I'll copy the address right here or the path right here. Head over back to VS Code, and all I have to do is to paste in this path here. So this is the path to my root folder. So the next step we need is to instantiate a pre-trained model we need in training our model. So for that, we can say our model, and this is equal to our instance of our YOLO model. And in here, we YOLO have a lot of pre-trained models, so we have to choose from whichever one you like. In this case, we'll be using the nano version of the model. So all we need to type is YOLOv8 and -CLS. So this is the particular pre-trained model we'll be using, and this is the nano version of the YOLOv8 models. So if you want to use the medium model, you can just change the N there to M. If you want to use the large, you can use L. If you want to use the small, you can just use X. But in our case, we are using the nano version to train our model. So now we have instantiated the model we want to use. We'll go ahead now and train this model. So training the model is only one line of code usually, so we can just say result is equal to our model.train, and in here we just have to provide some couple of parameters for our model to train. So the first thing we need is our data, and this data will be equal to our data path. Then we need the number of epochs, and you can put this to some number of epochs you want. So you can normally the rule of thumb is that you increase this number because YOLOv8 will automatically apply early stopping if your model performance do not increase over time as is training. So you just have to put a higher number here. So you can put any number you want. In my case, I can just put 500, and I know before 500 epochs will elapse, early stopping will kick in, and that's it. Okay, the next thing you would like to put here is the image size. So imgz, and this I will set to 640. So you just have to put it like that, and that's all. So when we run this code, we'll kick off our training process and everything will go on successfully. So you have to follow these particular guidelines in order to train your custom model. So let me run this. So it will go ahead and download the pre-trained model for us. We are specifying the pre-trained model here. So it will download that pre-trained model, and then it will pick up the whole training process. So you can see the pre-trained model has been downloaded right here. And the next step is our model to train. Okay guys, so we ran into some errors here, and if I should check correctly, since we forget to add X here, so it's image and Z. So make sure the spelling here is actually correct, and then we'll run this once again. Alrighty, so guys, you can see our training process has begun. We have the number of epoch, GPU memory, and our loss and everything. So you can see we are 1 out of 500 epochs. I'm not going to wait for this model to train because I went ahead and trained one model which we will use for this particular tutorial. But what I'm glad about, the model is training and all the process we've gone through is working. So you can see now epoch 2 out of 500. So this will go ahead and train our model for 500 epochs. I'll go over how to get your model after training. So over here you can see we have the folder called runs here. So immediately the model start training, this run folder will be created. And inside runs, you can see we have weights, args, result.csv, train batch, and whatsoever. But what is important here is the weights. And inside the weight, you can see we have best.pt and last.pt. So the best.pt is your best performing model that you use. So after the training process, you just have to use this best.pt model for running your prediction, or is a model you use. The last.pt also works, but mostly you have to use the best.pt because it's the best version of your model. Then over here, result.csv also gives you some results. So I said I'm not going to wait till the model trains because I've trained some of these models which we will use for our testing tasks. So I'll just cancel the training process, and what I'll do is that create another Python script, and in this script I'll call test.py, which we'll use for testing our model. Test.py is created, but what I'll do is to show you the model I've trained. When you come to the test data, you can see we have another rounds folder here, and this is the model I've created before this tutorial. Inside this we have classify. You open classify, we have train, and inside train you can see we have this. We have our weights. So this is the model we'll be using. We have best.pt and what last.pt. So over here we'll be using the best.pt. So I'll just copy its path, and it's the model we'll be using. And I'll go back to VS Code, and I'll just say model path, and this is equal to the particular path to our model. Right from here, we also import YOLO from authorities, and that is it. So this is our model path, and from authorities we are importing YOLO. What I also do is to bring in one image that we'll use for texting the model. Then we'll go ahead and create a Streamlit app where you can drag and drop images and get prediction. So for that image, I'll just say image, and this is equal to, or let's make it image path, and this is also equal to some image. I'm going to copy the path. So we just copy the path of one of the test images. Right here, I'll copy the path and I'll paste it inside here. Okay, so I'll go ahead and also import OPCV. So I'll import CV2, and this installs by default when you install Authority, so you don't need to install it again. And then I'll read the image using OPCV. So image is equal to cv2.imread, and over here we are reading our image path. Then what we'll do is to instantiate our model here. So we can say our model is equal to YOLO, and the model we'll be using is our custom model, which is our model path here. Okay, so now we can run predictions using this particular model. So you can just write your model, and then we'll feed it our image to get some prediction. Okay, so that's it. We have the image here, which we are reading with OPCV. So we just call our model, and then we feed in some image, and this will give us some prediction. So we'll store these predictions in result, and this is equal to our model. Then I think we can run this to see whatever we are getting. Okay, I'm not printing it, so let's print results. You can see we have a lot of outputs here. So within this output, all we need is the probability key. So we have to extract this probability and the names. So these are the two most important things. We need the probabilities and then the names, the class names. So I'll close this, and we have to go ahead and extract that. And that's it. So we can go ahead and print both the names and the probability. So I'll go ahead and run this. And over here, you can see our names returns cats and dogs. So the key of 0 is a dictionary. The key of 0 here stands for cat, and the key of 1 here stands for dog. So when we detect a class of 0, that means it is a cat, and we detect a class of 1, that means it's a dog. And then our probability here is also returning something. You can see it right here. So this returns a PyTorch tensor, so data, and it's a tensor, so we can even grab the data there. So props.data, and that's it. And one thing I would like to do is to convert this to numpy instead of PyTorch tensor. So .numpy. Okay, so let's close this and also run it once again. And here we go. So the particular image we are using is an image of a cat. So you can see data, and it's a cat. Let me show you the particular image we are using. So we are using this particular image, and it's an image of a cat. So the output here, we have 0.99 for cat and 2 point something for dog. So you can see strongly that what we are predicting here is a cat. And the reason I'm saying that is that the first key here, which is 0, stands for the class of cat. So the first key here also corresponds to the first index right here. So this believes that we are actually predicting a cat. Okay, so now that we are able to run predictions on our model, it's time we just go ahead and integrate this with a Streamlit app where we can just drag and drop images and see actual predictions in the textual form. So for that, I'll go ahead and install Streamlit. So let me run this once again so that I'll get the terminal and install Streamlit. So I'll say pip install Streamlit and hit enter. This will go ahead and install Streamlit for us. So the installation process is done and I can close this terminal, and what we will do is to import Streamlit. So we'll import Streamlit as st. So now we've imported Streamlit. The first thing I'll do is to create a title. So you can see st.title. Streamlit is very easy to use. And over here, so I'll just put something like drop your image for prediction. Okay, so should it be drop or it should be insert? Let's just use insert instead of drop. So insert your image for prediction. Then over here, we can put it into parentheses that dog and cat. Okay, so I think this looks good. Then after this, you have to create a file uploader. So we'll call this our image, and this is equals to st.fileuploader. So inside here, we can give it a label that, okay, upload your image. And the next thing I'll do is to specify some types of image we want. So we can say types, and this takes it as a list. So we'll need PNG, we accept PNG images, JPEG, and so on. Okay, so these are the image extensions we'll be accepting right here: PNG, JPEG, JPG, and GIF. I don't know how to pronounce that well. So GIF. Okay, so now I have to check whether someone has dropped an image or somebody has uploaded an image. So we say if there is an image, we are going to read this image. So we can use the pillow library. So from or PIL. So right here, what we'll do is that I'll say my image is equal to image.open, and over here we are taking our image. So once we grab this image, we can now run this image through our model and then we get some prediction. So all of this code can now come up, and then after here, all we need is to bring in, okay, our model loading should also go up. We can bring in this right here to our model, and then we are inserting this particular image. So let me copy this, and then we can do the other things we are doing, and that's it. So this is all we need to do. I think I can even comment the image reading part using the OPCV because we don't need it anymore. So we can comment this, we can also comment this, and with this our Streamlit app is ready. So let's run the code and then kick this app up and see how it runs. So to run a Streamlit app, you just have to write Streamlit run, then the name of your app, that is test.py, and you hit enter. So this will just open your browser, and then this app will run by default. So you can see insert your image for prediction, dog or cat. Then over here we can just insert any of the images. So go to desktop and then our test data, and you have some images here. So we can just upload an image of a cat and this will run through the model. Okay, so one thing we can also do is that after receiving the image, we can also put this image on the screen. So we can say st.image, and over here we just pass in our image, and that's it. So when I save this automatically to update, click on always run, and you can see the image is now here. So now we just have to put our prediction right under the image, and that's it. Okay, so over here we can use numpy. So let's import numpy. So we are importing numpy as np, and then we can just come down here and I'll say our prediction is equal to np.argmax, and inside here you just put in your probabilities. And what we'll do here is that if we can say if our prediction, but before we do that, let's even write that. So we use st.write, and then we write our prediction. So you can see it returns 1 right here, which means it's a dog. because from the beginning we know the class 0 or the key 0 here belongs to cat and the key 1 here belongs to dog. So I think we can also write that st.write, and what we are going to write here is the names so that we can keep track of that. Then we can add if statement here saying that if our prediction here is equal to 0, then we'll write that our result is a cat. So this is a cat, not a dog. Otherwise, our prediction is a dog. So if the number returned by our argmax function is 0, then it's a cat, but any other number it returns is a dog. So if it's not 0, it will be 1. So if anything 1, then we know we are predicting a dog. And that's what we are doing right here. So let me open this once again, and you can see this is a dog, but for the moment of truth, let's update one cat image and see. So this will go through the model, and you can see this is a cat. So we have 0 for cat and 1 for dog. So with this, you can just open updates with some images and get some results. So this is a dog. So this model is working good, and it's working great because I've trained this with about 100 and something epochs. Is it 120 or so epochs? And then early stopping kicks in because the model have successfully trained and the performance is not increasing over time. So early stopping kicks in. That's it. But after testing the model, I'm very happy because the result is fantastic. I just put in any image at all of either dog or cat and it's able to classify it. So you can see this is a cat. So guys, this is all for this tutorial. The code, including the files and everything we use, will be on my GitHub repo. And you know the link will be in the description for you guys to use this for yourself. If you have any comments, just put it in the comment section. I'll be glad to answer your comments and also help you out for you to make this particular tutorial work in your use case. Thanks for watching. I'll see you in the next tutorial.